The absence of proper affordable housing is still one of Sub-Saharan Africa's biggest problems. Especially now with rampant inflation and dropping currency rates, access to affordable housing is more important than ever before. It is Betoniq's goal to become the #1 provider of affordable housing products in this region. What is the Betoniq approach? In Sub-Saharan Africa, about 3 times the amount of rain falls compared to, for example, Europe. It is moist and mostly not too hot. With the many thunderstorms, however, rain comes down hard and fast. This is why wood, plywood, plasterboard and light steel frames are not popular. Moist destroys these materials too fast. The climate basically forces people to build using concrete blocks and floors. In this climate and market that chooses cross-ventilation and fans, it is clear that building houses using concrete is the way to go. There is no need for wall insulation because windows are almost always open. This lack of training, the harsh climate and theft of construction materials, are the main reasons that affordable mass housing using traditional on-site construction always seems to fail. How to improve affordable mass housing? By using precast concrete construction, and by finishing all panels in a factory, on-site construction work is reduced to a minimum. This is key to be able to create high-quality affordable housing. Concrete that is casted in a factory is 3 times stronger than concrete casted on-site, like concrete floors. Reinforced factory precast concrete is probably over 10 times stronger than the sandcrete blocks that are used and produced everywhere and by anyone in Africa. Precast concrete walls are also perfectly smooth. That is why there is no plaster work needed anywhere. With this strong and accurate concrete and with the absence of wall insulation, we are able to create doors and windows without door and window frames. We apply rubber strips, hinges and locks directly onto the precast concrete, which is not only a massive saving in material and construction speed, but also saves large amounts of maintenance costs. What is holding precast concrete technology back? With the innovations as mentioned above, we are able to prove that we can build affordable housing cheaper, with a much higher quality and at a much higher speed. Now, why is this technology not used in Sub-Saharan Africa, you might ask? First, you need to cover the entire construction process. When you don't include all finishing aspects, all the on-site issues remain and you never achieve the ultimate construction speed and quality. Secondly, the investment in a modern precast concrete factory is massive. The existing large construction firms in Sub-Saharan Africa make more money in medium and high-end apartments and in office buildings. These companies are not focused on affordable mass housing. They will only look at the disruptive technology of the Betoniq concept once it starts eating away their markets. That is why our investors need to be disruptors. Visionaries that see and create a new affordable mass housing market. They will do it with a technology that will ultimately also take over middle and high-end housing and other construction segments like offices, schools, hospitals, barracks and police stations. Thirdly, we needed to highly automate the design, costing, production and assembly process. The main problem of precast concrete is the extreme complicated preparation process. Every panel holds many details for connections, transport, hoisting, and we now also added finishing to it. Because panels are costly to detail and to create molds for, you see too much repetition in existing mass housing projects that use precast concrete technology. Without the repetition, it simply gets too expensive very fast. Luckily, something important has changed recently. We can now teach computers to detail precast concrete properly. Like chess, we can describe all the rules that create the details of connections and rebar mesh in a precast concrete panels. We have rules about the maximum weight the overhead cranes, trucks and crawler cranes can manage. All these restrictions can be described in a mathematical design system. In that expert system we also connects all price variables to the design. Cubic meters are translated to tons of cement, sand and aggregate based on our concrete recipe. The automated rebar design is also calculated to tons of steel. And with current preset prices we can now do a real-time costing while we are designing the dimensions of a wall panel, a gutter, or a balcony floor panel. Because software is now able to translate all these rules to a full 3D design, and laptops are now fast and large enough to process all this data. Betoniq is now the first company to make a 100% parametric building design that can also actually be produced using these parameters. This is because the rebar-producing robots, the shuttering robots, 3D printing concrete machines and the logistics in the Betoniq factory, all use the data of the parametric design. All this was necessary to increase the design flexibility to a much higher level and reducing the extreme high design and static engineering costs of precast concrete construction to a minimum. With this groundbreaking new technology, the door is now open for machine learning to use the Betoniq rules and regenerate existing building designs to buildings that can be actually produced in the Betoniq factories. So ultimately we can have unique one-off tailor-made houses and other buildings from a mass production facility. With this state-of-the-art technology, Betoniq holds the key to disrupt the affordable mass housing markets in Sub-Saharan Africa, and likely opened the door to a full-spectrum construction revolution. The German and Italian world market leaders in precast construction machines support our technology, as do the German banks. The only question is if you, as an investor, want to be part of our disruptive technology. We hope to see you soon.